Aneuploidy means there is a change in the number of, is the phenomenon, aneuploidy is the phenomenon in which an organism possesses a chromosome number that is not an exact multiple of the monoploid number, that is aneuploidy. And just I'll brief of what we have told. Then aneuploidy is mainly caused due to an error in the cell division called non-disjunction. And non-disjunction is of two types: primary non-disjunction and secondary non-disjunction. Primary non-disjunction happens if there is abnormality in meiosis 1, and secondary non-disjunction occur during the second meiotic division. And if primary non-disjunction occurs, all the gametes which are formed will be abnormal ones. And if secondary non-disjunction occur, half of the gametes will be abnormal and half will be normal. Then we have told what trisomy is. That is when a gamete containing an extra chromosome is fertilized by a normal gamete. That is 2n plus 1. That condition 2n plus 1. That is, if a 2n gamete fuses with n, that type of individual, the resulting individual will be having 2n plus 1 number of chromosome, and that's known as trisomy. Then when a gamete with a missing chromosome is fertilized by a normal gamete, that is called monosomy. That's called monosomy. And when the individual have 2 chromosomes less than the basic number, that is 2n minus 2, that is called nullisomy. Then aneuploidy involving loss of chromosome from the normal number is called hypoploidy. And if there's increase in the number, that is, if total, I said there are 46 chromosomes in a human being, if it is 47 or 48 normal condition, that means there is an increase in the number from the basic number. That is, 46 is the normal number of chromosome, and in abnormal case, if it is 47 or 48, that condition is called hyperploidy, and if it is 45 or 44, that's called hypoploidy. And hyperploidy, the examples are, the two types are trisomy and tetrasomy. Now we'll see an example of each case, that is monosomy and trisomic condition. First is monosomy. Monosomy, as I have said, the individual having one chromosome less. That is monosomy, 2n minus 1. An individual having one chromosome less in its diploid complement is called monosomic, 2n minus 1. That is, the chromosome number will be 45 instead of 46. 2n minus 1, they will be having 45 instead of 46 number of chromosomes. That condition, monosomic condition, is called Turner syndrome. And Turner syndrome is a genetic condition that only affects the females. And it was named after Dr. Henry Turner, who discovered the condition in 1938. Turner is the name of the person who first discovered this abnormality. Usually, monosomic individuals, they will be lethal. Usually, the nature always try to eliminate the abnormal organisms, plants, or whatever it is. If it is not viable, that is known as natural selection, because nature always selects the best or the viable ones. So, monosomy, in several cases, monosomy is lethal, or that individual will be dead to the affected individuals, and non-disjunction of the sex chromosome in man results in a monosomic condition called X O. Hmm? And these individuals are viable, but they are sterile. They are sterile females, and this condition is known as Turner syndrome. And they have the Turner syndrome individuals. They will be having 44 autosomes. Total human beings, we have 44 autosomes and one pair of 6 chromosomes. And in case of males, it is 44 plus XY, and in females, it is 44 plus XX. In case of the Turner syndrome, they have 44 autosomes and one X chromosome. This will be missing. This is the genetic composition, or this is the chromosome composition of the individual suffering from Turner syndrome. They have 44 autosomes, but one X or Y will be missing. So they will be females, but they are sterile. And because this is something related with the sex chromosome. Then physical characteristics of the physical characteristics of this individuals, they have characteristics, they look almost, I said they almost look like females, but they have reduced characters when compared to a normal female. Some difference, by at the appearance itself we'll be able to identify such individuals because they have some characteristic features, like they're having it's not moon face, but they have the eyes will be partially closed, or it will be like a drooping eyes, look like that, and that's like one characteristic facial feature and looks. Then another one is they have a fold of skin at the neck, which is almost like that of some old ladies, that the skin and the neck will be loose compared to the people of the same age group. And usually the Turner syndrome or Down syndrome, people who are having syndromes, they will be having serious abnormalities with heart. They have some congenital, by birth itself they will be having some abnormality. They will have some abnormalities related with the functioning of heart, and usually they have reduced IQ. Then they almost look like females, but the secondary sexual characters will be poorly developed. That is, widely placed nipples which are poorly developed. Then elbow deformity is there in case of this people who are having Turner syndrome. Then rudimentary ovaries. Ovaries are there, but they are rudimentary, because it is rudimentary means not developed properly. That is rudimentary. If it is rudimentary, the hormone production from such structures will not be proper. So the person or that female will not have the looks of a normal feminine characters will be absent, because the feminine expression or feminine characters are as a result of the production of hormones from these structures such as ovaries. So rudimentary ovaries, it's a streak underdeveloped gonadal structures. The gonadal structures will be poorly developed and they don't have a reproductive cycle, because it is the ovaries are poorly developed, so the production of ovum etc. is not there. That is what they are. That is why it is said they are sterile, because the this character, that is production of gamete, is arrested. So these individuals will be sterile, and they have some round spots on their body. Their fingernails will be very short, shortened metacarpal, widely placed nipples, shield-shaped thorax, the thoracic region, because it's like a shield on the warriors or someone like that. That's a shield-shaped thorax is present. They have, overall they have a short, stubby stature. Then this monosomy condition or XO, and these are the individuals will be having monosomy, that is 44 plus XO. Let's see how this is the chromosome complement of, or chromosome structure of the number of chromosome in this individuals who are having this abnormality. Then the exomonosomic condition originates from the exceptional X or sperm. If there is this is a individual. Just imagine an individual who is having 44 autosomes. A male will be having plus XY. This is the male parent and 44 autosomes plus XX. This will be the female parent. Let's see how the abnormal condition arises. And if non-disjunction takes place, the normal gametes which are supposed to be produced from this is 22 autosomes plus, it should be either X, one gamete will be 22A plus X, another gamete will be 22 plus Y, because this is the male parent. That is a normal condition. And in females, normally the female parent will have 44 autosomes plus 2 X chromosomes. And normal condition, 22 autosomes plus 1 X will be one gamete, and 22 autosomes plus 1 X will be another gamete. That is a normal condition. And if non-disjunction is happening, what happens here is this one gamete will be having this X and another gamete will be having 22A plus 0. Missing X or Y chromosome. Then here, if the male-female parent is normal, that is, it is having 22 autosomes plus X. If these two gametes fuse, the individual formed will be having 44 autosomes plus X0, because this gamete X and Y is missing. This gamete X and Y chromosome is missing, and this is one manner through which 44A plus XO condition arises. XO monosomics probably originate from exceptional X or sperms with no X chromosomes. The chromosome must be lacking, or from the loss of a sex chromosome in mitosis during early cleavage stages after an XX or XY zygote is formed. Even after X or Y zygote is formed, a normal is formed, and there, as a result of mitosis, if some change occur also, it will be deleteriously affected. And this is how 44. So if this person is having is exposed to some radiations or anything like that, any cause, physical cause, chemical cause, and as a result of any of these causes, the abnormal or unreduced gamete will be formed in the male. The reverse can also happen. Okay, there can be some abnormalities in the female also. We can write that also. That is, if it is another condition is Another condition is 44 autosomes plus XY. This is the male parent 44 autosomes plus XX. This is a female. If non-disjunction, and from here the two types of gametes formed can be 22 autosomes plus X, and this can be one gamete. Another gamete is 22 autosomes plus Y. These are the two types of gametes which can be formed from this individual. And here, as a result of non-disjunction, if the gamete formed is 22A plus XX. This is one gamete, and another gamete can be 22 autosomes plus 0. This is missing of X or Y chromosome. And if this gamete fuses with this, also a trisomic individual will be formed. 44 autosomes plus XO. So the abnormality can be from either from the paternal or from the maternal side. That is during the unreduced, a result of some agents. If unreduced gametes are formed as a result of non-disjunction, that can lead to this monosomic condition or Turner syndrome. Now, next is nullisomy. Nullisomy is an individual having two homologous chromosomes less than the normal complement, that is 2n minus 2. 2n minus 2, that is nullisomy. Null effect, that is nullisomy. Two chromosomes will be missing. That is nullisomy. An individual having two homologous chromosomes less than the normal diploid complement is termed as nullisomic. Nullisomic individuals might result from the union of two monosomic gametes. Nullisomic might have originated from nullisomy means nullisomy if this gamete like this null may fuse together to form another null. This is how that's known as nullisomy. An individual having two homologous chromosomes less than the normal diploid complement is termed nullisomy. And nullisomic individuals might result from the union of two monosomic gametes or due to the non-disjunction of a homologous pair during anaphase. Usually these nullisomic individuals fail to survive, and even if they survive, they have reduced vigor. Usually this, as I said, nature selects the best. So if they are formed after a few days, the lethal condition will arise. The next is trisomy. Trisomy, if an individual is having an extra chromosome, that's known as trisomy, basic number plus 1. An individual with an extra chromosome over the normal diploid number of chromosome is called trisomic condition. And the trisomic individuals are fairly common in species including Drosophila, Datura, then Zemes and man. It's a disorder. The Klinefelter syndrome in man is characteristic of this trisomy. Trisomy condition is characteristics or the trisomy condition is example is Klinefelter's syndrome, and it is in man. Klinefelter syndrome is characterized by the change in chromosome of the sex chromosome, that is XXY. And XXY can be formed as a result of non-disjunction. In the previous example I said, as a result of non-disjunction, the gametes will be, one will be 22A plus XX, another will be 0. And if this XX fuse with a normal Y gamete, XX fuse with a normal Y gamete, XXY can arise. And that condition is known as Klinefelter syndrome, that is a trisomy of sex chromosome. Because this is a change in the number of the sex chromosome, and that's known as Klinefelter syndrome. Klinefelter syndrome. Klinefelter syndrome is a syndrome in which there is a change in the number of sex chromosome, and this arises as a result of the fusion between 22XX plus 22Y. Then as a result 44 autosomes plus XXY individual will be formed. Clear? This is known as Klinefelter syndrome, and that is related with the sex chromosomes XXY. This is also a trisomy because one number increased, trisomic condition. Then next is Down syndrome. Klinefelter syndrome. But different from the Klinefelter syndrome, Down syndrome, it's associated with the autosomes. Here, the 21st chromosome will be trisomic. In Down syndrome, the 21st chromosome is trisomy, and this occurs as a result of primary non-disjunction. Because that abnormality or the inappropriate segregation of chromosomes takes place in the first meiotic division, and that's known as trisomy 21 because change of number in the autosome. These are autosomes, and this is sex chromosome. This is a karyotype of a female. This is sex chromosome, and other are autosomes. And coming to the number, if you write, you will be having autosomes instead. You have 45 autosomes will be there. Usually we write 44, but here we will be having 45 autosomes. 45 autosomes plus XX. This is Down syndrome. Down syndrome is also called Mongolism, as it is one of the best examples because the people who are having this Down syndrome will have a mongoloid face. Mongoloid race, they are normal people, but usually their face look different from other races. That's known as Mongoloid look, Mongolism. So now, but Down syndrome affected people or people who are having Down syndrome is said to have the appearance of a face of a Mongoloid race. So it's also called Mongolism. It is one of the best known autosomal disorder. 21st autosome. It's not related with the sex chromosome. It is related with the autosomes. 21ാമത്തെ ക്രോമസോമിൽ മൂന്നെണ്ണം വരും, രണ്ടെണ്ണത്തിന് പകരം മൂന്നെണ്ണം. That's known as trisomy in the 21st chromosome. Primary non-disjunction is the cause of this disorder. The Down syndrome occurs in about 700 live birth. Turner syndrome, 1 out of 1000. Down syndrome occurs in about 700 live birth, and the incidence of the syndrome rises with one reason. There are many factors. One reason behind this is the increase in the age of mother. Aged mothers will be have a chance of conceiving such babies, and about 40% of the Down syndrome victims are born to women over 40 years. Why is it? Because as age advances, a person's body will be having wear and tear. He may be or she may be exposed to so much of pollution. She may be exposed to chemicals. she may be exposed to, and as age advances, most of the internal organs as well as most of the organs in our body will function in a very not as efficient as in uh, 20s or 30s. So usually one reason is the increase in age of mother. Usually those who are 40 years above will have, but not all. Hmm? And there is, and individuals with this syndrome have a short stature, and they will be very small. They will be having a protruded tongue. These are some of the features. They have a mongoloid look. Then they have epicandal fold. That is, a fold is here. You can see a epicandal fold and upward slant of eyes. Eyes will be slanting. Usually we draw eyes like this, but this eyes will be slanting upwards. They have a small nose. Tongue will be always protruded, and they have a small flat nasal bridge. Then they have narrow short palate. Palate means the upper part of your mouth. They have a short narrow palate. And now, as the technology advances, and even though if an aged mother conceives, they can find there are many technology after amniocentesis, or even with the blood test, they can identify whether the baby who is inside the body of the mother is having any abnormalities. That is all about aneuploidy. So let me conclude. Aneuploidy is the phenomenon in which an organism possesses a chromosome number that is not an exact multiple of the N number or monoploid number. Aneuploidy is caused as a result of non-disjunction. Non-disjunction, two types, primary and secondary non-disjunction. Then as a result of non-disjunction, trisomy condition arises, monosomy condition or nullisomy condition arises. That is hypoploidy and hyperploidy. Hypoploidy means if it is less, not 46 is the normal number. If it is less than 46, the condition is called hypoploidy. If it is more than 46, 46 telling about the chromosome number of human being. If it is more than 46, then that's called hyperploidy. Then monosomy, as a result of monosomy, the syndrome is caused is Turner syndrome, that is affected because of the non-disjunction in the uh, gametes, that is the sex chromosomes. Then trisomy, Klinefelter syndrome is caused as a result of the change in the number of sex chromosome. Down syndrome or Mongolism is caused as a result of trisomy in the 21st chromosome. Now, next is structural aberrations. If some change happens to the structure of chromosome can occasionally undergo. Till now we were discussing about change in number. 46 change to 45 or 44, like that. That is change in number. That is chromosomal aberrations. That is numerical aberrations. That part is over. That is chromosomal aberrations. Numerical aberration is over. Next is structural aberrations. Structural aberrations. The chromosome can occasionally undergo change in structure, maybe as a result of some remarkable genetic sequence consequences, maybe because of the during a cell division, if a chromosome is moving to either poles of the cell, if some wear and tear occur to the chromosomes, and that is one reason for the structural aberration. There are many reasons. We'll discuss one by one. Then, in such chromosomal aberration, the number of chromosome usually remains the same. Structural aberration means the number remains the same, but the structure only differs. For example, if a chromosome is having 0.1 millimeter length, it will be reduced 0.001, like that. The length will be changed. This is only a simple, it's an exaggerated example. It's not a correct length or something like that. It just said that's all. The chromosome can occasionally undergo structural changes which may result in remarkable genetic consequences. And in such chromosomal aberrations, the number of chromosomes remains the same, but their genetic material becomes altered. There is some change in the structures. One part may be deleted, or one part, the deleted part may get attached to some other site of the chromosome, like that. Some rearrangement, gain or loss, rearrangement, shuffling, something like that happens in the chromosome. That's known as structural aberrations. And these changes are usually caused by the breaks in the chromosome or in the chromatids, and the broken ends may have different parts. As I said, they can immediately reunion. And the different types of structural aberrations are: 1. Deletion. 2. Inversion. Translocation. The name signifies exactly what is happening in the chromosome. Another one is duplication. And let's see briefly what each stands for. First is deletion. We'll just have a quick look at what exactly the term coined for, instead of going into the details. This is deletion, and this is a complete chromosome, as you can see. And if this part of the chromosome is getting deleted due to some mechanical pulling by this mitotic spindles of any spindle fibers or anything, microtubules, anything can cause, and as a result of that, if a part of chromosome is lost, this pink color region will be lost. This is a deleted genetic material, so this will be lost, and the remaining part will reunite. They will reunite, but this portion is missing. So the chromosome which is coding for certain proteins will be missed. This is known as simply what deletion is. So deletion is some breaks may appear on the chromosome as a result of some pulling or movement, or while during the movement towards the anaphase. Then a deleted genetic material. This one part of chromosome will be lost, and the remaining part will reunite, and that's known as deletion. Now, next is inversion. Deletion or deficiency means one part is lost. Then next is inversion. Inversion means this is inversion. Inversion is the condition in which this is a chromosome, some break has happened at this region as shown in the figure. Some breaks have occurred in the chromosome. Inversion means it is taking a rotation of 180 degree. This is 180 degree. Taking the chromosome, it will take a rotation of 180 degree. That is inversion. One part of the chromosome will break, and this cut end will rotate to a 180 degree angle. So it will take it will turn upside down. Here it was pink, here it was green. When it takes a 180 degree rotation, that is inversion, get inverted. Inverted means തിരിച്ച് കറങ്ങി വരിക, തലകുത്തനെയാകുക. That is simply what is known as inversion. So that is inversion, and as a result of inversion, after taking a 180 degree rotation, it will again rejoin, and this is the reinserted part of the DNA. Even though it is reinserted, there is change in the chromosome structure, because one part has taken a 180 degree rotation. That is known as inversion. This reinserted piece, or the piece will get inserted in the same place itself. That's known as inversion. Now, next is duplication. This is simply merely the basics of what is happening. In detail, we'll explain the next sessions. Then duplication or mutation. Duplication is the addition of the chromosomal segment. Here you can see this is one chromosomal segment which is shown in yellow color, and this is the length of the chromosome. You just have a look at the length of the chromosome, length between these two chromosomes. This is this much length difference is there. Just have a look at these two chromosomes. The first one is shorter and this one is longer. And here, an additional segment has been inserted here. This is known as duplication. One part of duplication is the addition of the chromosomal segment to one of the already existing chromosome, and that is known as duplication. So as a result of duplication, dual means same gene chromosome part will be duplicated. Here only one, here one and two. The same units are repeated, and as a result the length of the chromosome also changes. This is known as duplication mutation, and as a result a section of the DNA is duplicated. Here more genetic material than the first chromosome. First chromosome have only this much genes. This is the chromosome length, and inside that this much only genes are there. Because this part of the chromosome is duplicated, they have an additional number of chromosomes with the increase in the length of the chromosome. Chromosomeന്റെ ലെങ്ത് കൂടുന്നതിനനുസരിച്ച് ഒരു പാർട്ട് ഓഫ് ക്രോമസോമിന്റെ കൂടെ അവിടെ അഡീഷണൽ ആയിട്ട് വരുന്നതുകൊണ്ട് അത്രയും ജീൻസ് കൂടെ വരികയാണ്. ദാറ്റ്സ് നോൺ ആസ് ഡ്യൂപ്ലിക്കേഷൻ. ഡ്യൂപ്ലിക്കേറ്റ് ചെയ്യുക മീൻസ് ഇൻക്രീസ് ചെയ്യുക. ദാറ്റ് ഈസ് ഡ്യൂപ്ലിക്കേഷൻ ഇസ് അഡീഷണൽ ഓഫ് ക്രോമസോമൽ സെഗ്മെന്റ് to the already existing chromosome, and that is known as duplication. Then next is translocation. Translocation means ഇതുവരെ നമ്മൾ പറഞ്ഞത് എന്തായിരുന്നു? ഇൻസേർഷൻ ആണെങ്കിലും ഡിലീഷൻ ആണെങ്കിലും ഒരേ ക്രോമസോമിൽ ഒറ്റ ക്രോമസോമിൽ നടക്കുന്ന ചേഞ്ചസ്. ഒരിടത്തു നിന്ന് ഡിലീഷൻ എന്ന് പറയുമ്പോൾ ഒരു ക്രോമസോമിൽ ഒരു പാർട്ട് മുറിഞ്ഞു പോയി. ഇൻവേർഷൻ എന്ന് പറഞ്ഞപ്പോഴേക്കും ഒരു പാർട്ട് മുറിഞ്ഞ് ഒന്ന് ഇൻവേർട്ട് ചെയ്ത് 180 ഡിഗ്രി കറങ്ങി അത് അവിടെ തന്നെ തിരിച്ച് ജോയിൻ ചെയ്യുകയാണ്. അടുത്ത ഡ്യൂപ്ലിക്കേഷനിൽ ഒരു സെഗ്മെന്റ് തന്നെ ഡ്യൂപ്ലിക്കേറ്റ് ചെയ്യുന്നു അതേ ക്രോമസോമിൽ തന്നെ. അങ്ങനെ ഒരു സെറ്റ് ഓഫ് ഡബ്ലിംഗ് ഓഫ് ജീൻസ് ഉണ്ടാവുകയാണ്. കൂടുതൽ ജീൻസ് വിൽ ബി പ്രസന്റ് ഇൻ ദ ക്രോമസോം. ഇതിനെയാണ് ഡ്യൂപ്ലിക്കേഷൻ എന്ന് പറയുന്നത്. ഇനി നെക്സ്റ്റ് ഇസ് ട്രാൻസ്ലൊക്കേഷൻ. ട്രാൻസ്ലൊക്കേഷൻ എന്ന് പറഞ്ഞാൽ ഹിയർ യു ക്യാൻ സീ ദിസ് ഇസ് ട്രാൻസ്ലൊക്കേഷൻ. ട്രാൻസ്ലൊക്കേഷൻ മീൻസ് ഒരു സ്ഥലത്ത് ഒരു ക്രോമസോം ബ്രേക്ക് ഉണ്ടാവുകയും അവിടെ നിന്ന് ആ ക്രോമസോം മുറിഞ്ഞിട്ട് വേറെ ഒരു ക്രോമസോമിന്റെ പാർട്ടിൽ പോയി attach ചെയ്യുകയാണ്. That is known as translocation. Here you can see the chromosome. Just have a look at this chromosome A and chromosome B. Chromosome A and B, this is white in color and this is black in color, and cut is here. One region, and here also a cut has occurred. And this chromosome, as the arrow indicates, it can have the arrow indicates, see, a cut is here. The cut is here, this part, cut is here, that is cut has happened here. E part lo cut undai, e part lo that is the cut. എന്നിട്ട് ഈ part will move to this part of the chromosome, and this part of the chromosome will move towards this region, and as a result of that the new combination has arisen. Here this is the chromosome which is formed as a result of this translocation. This has moved to this region and this has moved to this region. This is known as translocation, movement or of the part of chromosome from one region. Translocation means there is a change in the position, or the translocation is simply the change in the position. Is the transfer segment of chromosome to a different part of the same chromosome. Same chromosome ilagam. It can be same. If ividanna murinjittu this part of chromosome can even ഇവിടെ ഒരു കട്ട് ഉണ്ടായിട്ട് ഇങ്ങോട്ട് വേണമെങ്കിലും വരാം, സെയിം പാർട്ടിലോട്ട് വരാം. It does not mean it always moves to other chromosome itself. It can move to the same another part of the same chromosome. Translocation means പൊസിഷനിൽ മാറ്റം വരികയാണ്. ഒരിടത്തുനിന്ന് എഴുന്നേറ്റ് അത് വേറൊരിടത്തോട്ട് ട്രാൻസ്ലോക്കേറ്റ് ചെയ്തത്. മീൻസ് ഇറ്റ് ചേഞ്ചസ് ഇറ്റ്സ് പൊസിഷൻ, ഓർ ദ ട്രാൻസ്ഫർ ഓഫ് സെഗ്മെന്റ് ഓഫ് എ ക്രോമസോം to a different part of the same chromosome or to a different non-homologous chromosome. Same chromosome ilagam allengil veroru non-homologous chromosome lotu varam, and that is known as translocation. So these are the different types of structural aberrations. To conclude this tutorial, I will say the structural aberration is chromosome undergoes some structural changes, not number change, structural changes, and this structural change is due to the change in the genetic sequences. May change. And the different types of structural aberrations are deletion, then inversion, duplication, and translocation. And we have briefed here what is simply what happening during this segments, during these type of movements. And with this, we come to the end of this tutorial. Thank you for watching.